When you check out at the pharmacy, you see the journey from idea to medicine, thanks to our intellectual property system, or IP for short. IP safeguards inventions, like a new way to prevent seizures or lower cholesterol. And IP supports competition from other brands. Then, lower cost generics, which are 90% of prescriptions filled in the US. Innovation, competition, lower costs, thanks to IP. Learn more at phrma.org/IP works wonders.
The Defense Department is planning to spend billions of dollars on satellites that communicate by laser. But officials at the Space Development Agency can't say for sure whether space laser communication even works. Or at least all of its contractors haven't shown this capability. We get more now from the director of the Contracting and National Security Acquisitions team at the Government Accountability Office, John Ludwigson. John, good to have you back.
Tom, thanks for having me back.
And this program does seem like they're full steam ahead. As you report, they're spending billions in different tranches of money to put these satellites up. What's going on that they don't have reliable technology for the whole basis of the program?
Well, I think this is part of what's referred to as the proliferated warfighter network that is designed really to provide a low Earth orbit, so closest orbits to the Earth capability to do a variety of missions, including missile warning, missile tracking. And to do that mission, pretty technically complex, but it requires the use of lasers for the communication system because it provides a lot more capability in terms of bandwidth, the ability to push more data through the system. So the laser communications is really instrumental to demonstrating this overall capability. And so there's a lot of value to the LEO orbit approach.
Right, so they're looking at basically optical communications because the satellites will be close enough in satellite terms that you won't get this giant propagation width of the optical signal.
Yeah, so laser comms offer a lot of value in terms of being able to transmit a lot of information. There are going to be hundreds of satellites, and in fact, considerably more over time as the program ramps up, if it does so as planned. But the ability to communicate across those satellites and connect, say, because they're going to be in orbit as opposed to a geostationary orbit where it's always looking down at the same location, these are going to be moving. And so in order to identify a missile and to track it requires multiple satellites to keep eyes on it and transmitting that data so that the warfighter can have the information available to them. It's pretty complex.
And they envisioned communications among the satellites and also between the satellite cluster, if you will, and, of course, the ground. Eventually, it's got to get down there.
Correct. Yeah. So the satellites would send signals to each other, and then they would find an opportunistic downlink. So the ability to move the data down to the warfighter. And the communication network, I mentioned the missile warning, missile tracking mission. That's part of it, but this could be a true communications web that would provide the ability to communicate with vehicles or boats or planes as necessary.
All right. And what is the status of that capability of laser communications? Your report says that it's hardly proven at this point, and yet they are planning to launch the first batch.
Well, they already launched the first batch. So the Tranche 0, as they refer to it, was 28 satellites, which included both some satellites dedicated to missile warning, missile tracking, as well as the communication satellites that we're focused on. All of them have laser communications terminals on them, but the ability to do that is challenging. And so in order to make the connection, if you can imagine a flashlight in a room, you have to point, acquire the target, and then track the target so you can transmit the data. And that's pretty challenging when you're talking about satellites that are at distances. So it's not me trying to shine a flashlight across the room. This is, perhaps thousands of miles.
And does it require very precise precisioning, or can the beam receiver have some, flexibility in where it points? In other words, could it be like concave? And so even if it's a little bit off, it can still kind of catch the beam?
The beam really needs to be precise. So if you can imagine a laser pointer is probably the easiest thing that individuals can be familiar with. That beam is very small, obviously, when you generate it, but it's still very small at the terminus. So when you're trying to receive it, so you really need to be pretty accurate. You need to find it fairly quickly, be able to acquire that target, and then be able to track it long enough to make the data transmission complete. So it's a delicate operation to be able to do it. And the DoD has limited experience with this, and they've only demonstrated it between two of the vendors initially, and one of them had already done it commercially.
We're speaking with John Ludwigson, director of the Contracting and National Security Acquisitions team at the GAO. So it has been proven. I mean, I guess the only way you can really prove it is in space. There's no way on Earth to really try out this type of technology, it sounds like.
Well, they've done, limited bench testing, but the kinds of distances we're talking about are challenging to try to operationalize in a laboratory or ground-based environment. You really need to get up and fly because the perturbations as you move in space are something you need to cope with. You need to learn how to cope with, keeping it stable, keeping it from doing what people refer to as jitter. If you can imagine sort of bouncing if you're trying to do the operation I described with the laser pointer riding in your car, right? That's only a limited three-dimensional experience. That would be challenging.
Sure, we've all seen it with laser pointer speakers and watching that little dot jiggle around there on the screen.
Absolutely.
And, well, for Tranche 0, so is it working, not working, or semi-working?
Well, so this is, they're pursuing what we refer to as an iterative development. So the early stages, they established what they call a minimum viable product, and that was to develop the ability to have a mesh network, the ability to demonstrate that you can transmit data and do that in some somewhat complex ways to build the strength so that as you expand the system, you'll be able to do it in the more complex and more numerous, across more numerous satellites.
And for the plans of Tranche 1, 2, 3, and 4 of the satellites, I'm interpreting that GAO feels they need to have better proven communication skill before launching these things for billions and billions of dollars.
Yeah, and I think one thing I want to make perfectly clear is that the idea, the premise that SDA is using, the Space Development Agency is using here, is one that we support. We like the idea of iterative development, as it's called, because it does give you the opportunity to start with mature technologies and add more capability as the technologies that you need mature. And so you can do that every couple of years. The next batch of satellites could become more complex. But to do that, we think it's really important to demonstrate the minimum viable product before committing to increased layers of complexity and scale, and to incorporate the lessons that you've learned on the earlier tranches into the later tranches. Those are some of the foundational things that we've identified from leading practices that private industry uses, whether it's your car or electronic equipment that you use at your job.
All right, so then summarize. You've got a pretty long list of recommendations here. Well, big ones anyway. There's 4 of them. Summarize those for us. What do you think the SDA should do? Well, I think there are 4 recommendations in the report, and they really revolve around the idea that SDA should demonstrate its MVP, this minimum viable product that we're talking about, and incorporate lessons before proceeding to the next tranche. Make sure you've made whatever corrections you need to make, and to do that and to move on. So really we think that would be important before proceeding to Tranche 1 and before moving from Tranche 2 to Tranche 3 and from Tranche 1 to Tranche 2. So each of the stages, you should develop that capability and move forward.
And since they issued the report, it's really useful to make note that they've announced that they're going to delay the launch of Tranche 1, which is consistent with what we've identified in our report. And while they said that the delay is really focused on the availability of some of the equipment through the supply chain, the optical communications terminal, the laser terminals, we think that this delay does provide